this function in the form of an integral has to have a specific setup, and it does not have it. What is the setup? Only a number here and whatever over there. So my first step is to break this up. You can write whatever you want, it doesn't matter. Or not, just a symbol, it's fine too. T cubed plus 2 to the 4th dt plus, of course, from that number to e to x squared. And of the same thing, t cubed plus 2 to the 4th dt. This is okay, but this is not, because the lower limit has to be a number. So I have to swap that, and I have negative from the number to tangent x, t cubed plus 2 to the 4th dt, and then plus the second one, t to the 3rd plus 2 to the 4th dt. Now I'm ready to differentiate. All I have to do is replace t by tangent. But because this is not plain x, I have to multiply by the inner function prime. So I'm differentiating this as the outer and this as the inner. When I differentiate an integral, I get the function, but then this is the inner function, so I have to differentiate it. Plus, again here, all I have to do is plug it in. So I have e to x squared everything to the 3rd, plus 2 everything to the 4th power, and times, so I differentiated the integral, and now I have to differentiate this, which is e to x squared times 2x. Yes, here I can copy the base and multiply the exponents as the final simplified form. There is nothing I can do here. Maybe just use less parentheses. Tangent cubed plus 2 to the 4th secant squared. And then here plus 2x e to x squared, and in parentheses e to 3x squared plus 2 to the 4th. But there is nothing else we can do here. This is it.
What caused us to... Okay, so if it's just x, it goes through, just substitute. But if it's anything other than x, you multiply by the derivative of it?
Yeah, because I'm multiplying it by the derivative even if it's x, but it's 1. The derivative of x is 1. We always have to multiply by the inner function prime. And if it's x, I multiply by 1. I don't write it. But it's always, that idea should always be in the back of our minds. Nothing, I don't differentiate anything before I say times the inner function prime. If it happens to be x, then I have 1. But I always say times the inner function prime, always. Yeah, is that okay?
Yeah, I think so.
Good. It's like with factor and simplify. I always say, please factor simplify. Don't do anything before you factor and simplify. The same thing with differentiation. I always have to say blah, blah, blah times the inner function prime. Very good question. Anything else? So today we're reviewing for the final. Anything you'd like to go back to? Any chapter, any question, anything? Our last class is Tuesday. Next Thursday, we don't have a class a week from today. Final exams start Thursday, a week from today. Although I know we reviewed, and you can always go back to all the videos from the reviews for test 1, 2, and 3. maybe test 3 was very close, so maybe we don't need anything. But what about test 1 and 2? So we have chapters 2, 3, 4, and 5. Do you need anything from WebAssign? Anything from the homework that was due today? Or is due today? Was due today? Any question? Any topic? Name a topic and I can choose a problem like you just did with this. Was very good.
I generally have issues when trig functions are involved. So is there, or like trigonomic identities? I noticed those appeared a bunch in the WebAssign, but I had like no idea what they were.
So you're talking about integration, for example, with trig functions, or can you give me an example?
Yeah, like in integrations that involve using trigonomic identities.
Okay, so
Will that be something that we have? If not, I guess we don't need to go up for it.
Well, anything is possible because that's that's what we studied before, right? So here's an example if that's what you mean. I'm not sure what you mean exactly. So let me get just. What about this? Is that what you have in mind?
I think that was one of the problems, but sine 2x apparently is 2 sine x times cosine x.
Yes, this is very important. So indeed, it's a 2 sine x cosine x divided 1 plus cosine squared x dx. So this will be a huge issue in Calc 2. Not big, very big. Because of the trig substitutions. So in this class, we only learned simple integration and substitution. That's all we learned. But in Calc 2, you will learn many other techniques: integration by parts, trig substitution, and others. Okay, so this trig will become a major issue in Calc 2. Okay, so let's think about what we can do here. Any suggestions about the substitution on this problem?
1 plus cosine.
Well, let's go on that route. Let's go on that route. Remember, you know that you are on the right path, or you chose one of the good substitutions only if du is in the problem with no difficulties except a number. The problem with the number is never a problem, right? So when I differentiate this, I get 2 cosine x times the inner function prime, which is negative sine x. Of course, dx. Let me write it one more time because I didn't have room there. So du equals basically negative 2 sine x cosine x dx. There is no need to solve for dx because this is very simple. It's just a number. I can multiply by negative 1 twice. It's not going to make any difference. I'm not changing the problem. But now I know that all this is du. And I know that this is u. So the negative 2 sine x cosine x dx, du, and this is my u. So then from here, I have negative outside, and this is the integral from du over u, which is negative natural log of u plus a constant c. And then I have to go back and replace u. Since this is always positive, I will omit the absolute value symbol. Good. So that was very good. Very good question.
Will points be docked if you use the absolute value all the way through? Like, let's say you use absolute value instead of parentheses at the very end.
What I would like you to learn from me is at every step of the way, you ask yourself, do I need this? Do I simplify this? Do I factor this? Am I on the right track? So the answer is yes. You have to, at this point in your math adventure, at this point, you have to say, wait a minute. I know that this is always positive, and I know that when I add 1, these symbols will be redundant. Yes. I'm not saying it will be incorrect, but it will not be 100% correct either. It's a very good question. Thank you for that.
Can we do question 46, chapter 5.4 on the root normal?
I couldn't hear you 100%. So can you see? You said 46.
Yeah, question 46, chapter 5.4.
Is it from WebAssign or?
Textbook.
Oh, text. Oh, 46 should not be in WebAssign, actually. I should have thought about that. Okay. I'm opening there, you said, in 5.4. 5.5, 5.4, and this is for 46. Okay, so I'm assuming all this. Okay, I think I found it. Let me know if it's not the one. Okay, so the integral from 0 to pi over 3, is that correct? From sine theta plus sine theta tangent squared. Is this the one?
Oh, yes.
Over secant squared theta d theta. Okay, let me close this and move it away. Good. So let's see what we do here. Very nice problem. So like always, I say factor simplify, factor simplify, factor simplify. So the integral from 0 to pi over 3, I see that the numerator has a common factor, and I see that the denominator is also one term. This is the first thing I notice. I just copied the problem. I have never looked at it. So I see that this is a common factor, and I see that this is one term. I see that this is not a symmetric interval. I see that this function is continuous on 0 to pi over 3. Good. So then I proceed. Sine out, and 1 plus tangent squared over secant squared theta. Now I should remember this. How do I know this? Where does this come from? Very simple. Do we know what sine squared theta plus cosine squared theta equals to?
Is it 1?
Thank you. If you divide both sides by sine theta, sine squared of course, you get 1 plus cosine over sine squared is cotangent squared, and 1 over sine squared is cosecant squared. This is coming from here. Now, second step, if you divide this by cosine squared, we get sine squared over cosine squared, which is tangent squared, plus 1. 1 over cosine squared is secant squared. So these two identities come from the general identity. So that's how I know that 1 plus tangent squared over secant squared will be 1, because they are the same. So therefore, the whole thing simply changes into sine. That's it. So I have, which function prime is sine? Well, it's negative cosine theta from 0 to pi over 3. Negative. I plug in pi over 3. And remember, cosine pi over 3 is 1/2. And minus when I plug in 0, which is 1. So 1/2 minus 1 is negative 1/2 with minus in front is 1/2. This function is positive on 0 to pi over 3. So the answer must be positive. How do we know? Because we have this rule. If a function is positive or 0, the integral from f of x dx will also be greater than or equal to 0. Very good question. Thank you. Very easy to remember. This is when I teach pre-calculus, that's what I do with my students. We develop these on our own because it's easier to remember. Once you understand this, then you will understand and remember these two. Very good question. Thank you. Very good. Next question.